Today's lecture will complete our discussion in Chem 2070 of the theory of chemical reactions. And in Chem 2070, our theory of chemical reactions is really just reduced to a classification of reaction types. Last time we saw the most important reaction types were redox reactions, the most energetic reactions, and second, acid-base reactions. Today we will add to that the remaining two classes, the change of phase reactions and the most important example of those will be precipitation dissolution reactions. And then we'll look at some of the oddball reactions that aren't one of the above three classes, the insertion elimination reactions. In this first clip, we'll review some of the things we learned about acid-base chemistry. And what we saw was that there were the strong acids, and they're shown in red here. And let's discuss why these are strong acids. Why is HCl, HBr, and HI? Place in chat why they are strong acids. Place it in chat. They are strong acids because they involve the halogens. And halogens are the elements one column before the noble gases. They feel a particularly strong driving force to reach a filled shell. They're very electronegative. The electrons in these bonds are very much pulled towards the chlorine, bromine, and iodine. And by the way, this pull has a name, the inductive effect. So there's a very strong pull, and as a result of that pull, the H is strongly an H+. And since an H+ is an acid, that makes them strong acids. And then let's look at the remaining strong acids on our list, which are HNO3, HClO3, H2SO4, HClO4, and I'll add one more, H3O+. And put in chat, what do these five strong acids share in common? Besides the fact they're strong acids, what do these five strong acids share in common? Put it in chat. And they share that the central atom is positively charged. And I'll do the one that I didn't do in the previous examples in yesterday's lecture, HClO3, which is chloric acid. Each of these acids have names, important names, which I'll write for you once again. Nitric acid. This one is chloric acid. Sulfuric acid. Perchloric acid. And the hydronium ion. So they all share in common that the central atom is positively charged. We'll look at it for chloric acid right here. let's see, its steric number is, well, I'll just draw it out. Cl, OH, O minus, O minus. I'm not drawing the lone pairs. 2 plus. There's the atom more in the center. It's not a really central atom molecule, but that in the center is a 2 plus. And this is that plus charge in the center. And that plus 2 charge is going to bring the charges, the pair of electrons in the bond will be attracted to it. All the electrons are being attracted to it. Put in chat what's the name of that effect, where all the plus charges are in the bonds are attracted to that very plus charge in the center. Put in chat what it is. Starts with an I. Starts with an I. Put it in chat. That's right. This is the inductive effect. And therefore, this H has lost. This pair of electrons has been drawn away from it. The H is very plus charged. And therefore very acidic. And so all our strong acids have the feature that they're very, very strongly plus charged, the H. And finally, just as a final reminder, put in chat, what is the exact definition of a strong acid? What is the definition of a strong acid? Put it in chat. The definition of a strong acid is it's a stronger acid than H3O+, and that'll be important later in today's lecture. And in the same way, we can look at the strong bases, which are written in green. They are the alkali metal and 3-amigo. The 3-amigos, remember, are the heavy alkaline earth, hydroxides, and oxides. And place in chat why we know that the 3-amigo alkaline earth oxides and hydroxides and the alkali metal oxides and hydroxides are strong bases. Put that in chat. And the reason why we know they are strong bases is that we think of this cascade. H3O plus is a strong acid. Each time we remove an H plus, it becomes a weaker and weaker acid. It becomes a stronger and stronger base. And so O2 minus is a very strong base. The definition of a strong base is that it is of equal or greater basic strength than OH minus. And so the reason why the alkali metal and the 3-amigo alkaline earth hydroxides and oxides are strong bases is, let's take for example potassium hydroxide. In the case of potassium hydroxide, this is very much, it's very electropositive. It is very much potassium plus, which means that the OH is very much OH minus. Or I could look at an alkaline earth. I can look at strontium oxide. Calcium, strontium, and barium are the 3 heaviest alkaline earths. They are the 3 alkaline earths furthest from fluorine. They are therefore the most electropositive. And again, Strontium and strontium O is very much strontium 2 plus. The O is very much O2 minus, and having an OH minus or having an O2 minus is the definition of a strong base.